Hello, so we have a question on board that is 2 to the power x plus x is equal to 5, and we have to find the value of x. Now how do we go about it? So first of all, let's have 2 to the power x to be equal to 5 minus x. I'm going to have 5 minus x to be equal to 2 to the power x. Divide both sides by 2 to the power x. I'm going to have 2 to the power negative x multiplying 5 minus x to be equal to 1. Now the identity we use over here is when you have 1 over a to the power b, that can be rewritten as a to the power negative b. That's what we use over here. Now let's continue. So I'm going to multiply both the left hand side and then the right hand side by 2 to the power 5. And when I do that, I'm going to have 2 to the power 5 multiplying 2 to the power negative x multiplying 5 minus x to be equal to 2 to the power 5 multiplying 1. And when we continue with that, we are going to have 2 to the power 5 minus x multiplying 5 minus x to be equal to 32. Now another identity we use over here is when you have a to the power b multiplying a to the power c. Now over here, since the bases are the same, you are going to have a to the power b plus c. Good. So that's what we use over here as well. So if we continue, we are going to have 5 minus x multiplying 2 to the power 5 minus x to be equal to 32. Now we are going to introduce something called the natural log, ln and e. Now when we want 2 can be rewritten as e to the power natural log of 2. So e to the power natural log of 2 can be rewritten as 2. So if we want to introduce that concept over here, we are going to have 5 minus x multiplying the expression e to the power natural log of 2. That expression, this expression represents our number 2. And then we're going to have raised to the exponent 5 minus x is equal to 32. Now we are going to multiply the entire expression by natural log of 2. Multiply the entire expression by natural log of 2. And when we do that, we are going to have on the left hand side natural log of 2 multiplying 5 minus x multiplying e to the power natural log of 2 multiplying 5 minus x to be equal to 32 multiplying natural log of 2. Now another identity we used over here is that when you have a raised to the power b or raised to the power c, you can have this as a raised to the power bc. Now let's continue. Now we're going to have natural log of 2 multiplying 5 minus x multiplying e to the power natural log of 2 multiplying the expression 5 minus x to be equal to 32 natural log of 2. Now we can go ahead and take W Lambert's function on both sides, since what we have over here and here is the same. So when we take W Lambert's function of this whole entire expression and we take W Lambert's function of this one too, so we take W Lambert's function on the left hand side and on the right hand side. And W Lambert's function just tells us that when you take that function of, let's say, this expression a to the power a multiplying e to the power a this is going to give us just a. So if we compare, this is like our a multiplying e raised to the power a. So that means our whole expression, natural log of 2 multiplying 5 minus x, is our a over there. So when we simplify this further, we are going to have natural log of 2 multiplying 5 minus x to be equal to, on the right hand side, we are going to have W Lambert's function of natural log of 2 multiplying 32. Now over here, we can divide both sides by natural log of 2 divided by natural log of 2. And when we do this, we are going to have this as 5 minus x to be equal to W Lambert's function of 32 natural log of 2 divided by natural log of 2. And when we need x is just going to give us 5 minus W Lambert's function of 32 multiplying natural log of 2 divided by natural log of 2. Now we need to compute this entire thing. Alright, so when you compute 32 multiplying natural log of 2, that's going to leave you with a value of 22.1807. Now we are going to have x over here to be equal to 5 minus W Lambert's function of 22.1807 divided by 0.6931. And when you compute all of that, that's going to give you an approximate value of x, approximate value of 5 minus 3.284, an approximate value. So when you compute all of that, you're going to have x to be approximately equal to 1.716. Now, mind you, the W Lambert's function of this expression over here is a constant, so you can compute that using the calculator or using numerical methods. Now we found our x to be equal to 1.716, or approximately equal to 1.716. Now let's go ahead and test the value if it is correct. So the expression was 2 to the power x plus x equals 5. So we're going to have 2 to the power x plus x equals 5. But our x is 1.716. So we are going to have 2 to the power 1.716 plus 1.716. Is that equal to 5? Yeah, so that is approximately equal to 5.001. Yeah, so approximately. So we can say that our x is approximately equal to 1.716. All right, thank you very much for following through. Kindly like, subscribe, and hit the notification button for more videos. Thank you very much.